right, welcome back. This is unit 6.4, and this is oxidation reduction reactions. And in your reading, this is going to be page 672 to 678. And in your workbook, that's going to be 281 through 285. All right, so these equations that we're going to talk about now are called redox equations, and that's short for reduction oxidation. And these are only for single replacement reactions or reactions that include a single element. So it could also be something like a synthesis reaction where you have two elements that become a compound, or a decomposition reaction where you have a compound that becomes elements. It's also for combustion, because remember, in combustion you have your CH, your hydrocarbon, and then that's going to combine with oxygen. So their oxygen is going to be a single element, and that's going to produce carbon dioxide and water. All right, so sometimes it's most likely you're going to see them in a single replacement reaction, though. And this is reduction oxidation reactions happen when electrons are transferred from one element to another. And so when we're looking at a single replacement reaction, remember that the metal replaces the other metal according to this activity series. And we've talked about this activity series before. So the higher up the element is on this activity series, the stronger it is, and is able to replace only an element that's below it. So say, for example, if you had zinc and sodium, well, sodium is stronger than zinc. So if sodium was a metal by itself, it would replace zinc because it's higher up, so it's stronger. So in our example that we have here, we have silver chloride reacts with sodium metal. All right, so silver chloride. We need to get a formula for silver chloride. Well, we know that silver is Ag. And if we look on the periodic table, it's in the stair step with aluminum and zinc. So remember, aluminum is always a +3. So if you step down one, that's going to be zinc. That would be +2. So if you step down again on the periodic table, you're going to see silver. And so silver is a +1. So that's how you can remember the charge of silver. All right. And then chloride is Cl. Okay, if you look on your periodic table, that's always a -1. So since +1, -1 cancel each other out, then we just get AgCl for silver. Okay, so see right here, AgCl. And this reacts with sodium metal. So plus Na. All right, so there we see AgCl plus Na. Now, we have to look up silver and sodium on this activity series. So let's find silver. Silver is way down here. And then sodium is right here. So sodium is stronger than silver. So since it is stronger, it's going to push out silver. So silver is by itself. And then we're going to have sodium bonding with chloride. So this is going to be sodium chloride. All right. Now we have to make sure that we have the proper formula here. So we're going to have to do charges. So sodium is a +1, chlorine's a -1. So those cancel each other out. So that is the formula there. So make sure that when you're writing these equations, you check this activity series. You have to do that with every single replacement reaction. Because sometimes test writers will throw an equation on a test or something that the equation doesn't happen because the element that's bonded with the anion or the negative ion is already the stronger of the elements. Okay, so in oxidation reduction, we have to assign charges to all of these elements. That's the first thing that you do. So usually the oxidation number is the same as the charge. And when we get to exceptions on that, and I'll do some exception examples in class, but when we get to the exceptions on that, then I'll tell you what those rules are. But 98% of the time, it's just the charge of the element. All right, so let's look here. Remember we said silver was a +1, so we're going to go ahead and assign a +1 there. Chlorine's a -1. All right, so here's your first exception. Whenever you have an element that's unbonded by itself like this, its oxidation number is a 0. Okay, so I'm going to put a 0 there. Now we see silver here by itself, so I'm also going to assign a 0. So we have sodium. Sodium is a +1, and chlorine's a -1. So what we're looking for in this oxidation reduction reaction, is elements whose charge changes. So we see here silver is a +1 on the reactant side. But if we look over here on the product side, we see that silver is now a 0. So its oxidation number changed from a +1 to a 0. So how does something change from a +1 to a 0? Now, the only way that we could change that is by adding or taking away electrons. Because remember, if we take away protons, you may say, well, if I take away a proton, then the charge would come to 0 because I'm taking away a positive charge. But you can't take away protons, because once you start changing protons, what does that do? It changes the element, because remember, the element is identified by the number of protons it has in the nucleus. So if we took away a proton from silver, it wouldn't be silver anymore. It would be palladium, number 46 instead of 47. So we can't change the protons. The only thing that we can change to affect the charge is going to be the electrons. Okay, so remember, let's go back one screen. Electrons are transferred from one element to another. That sentence right there. So all we can do is transfer electrons. Well, if we have a positive here, how do we go to a negative? That means that we must put an electron here to counteract that positive charge. So if we add an electron here, this one electron is going to negate this, and so it will become a 0 charge. So you see right here, I've done that. This is what's called a half reaction. So if we have silver right here, that is a +1. I'm going to put the little charge up above it. If we add an electron to that, then it's going to go to silver with a 0 charge. Okay? Now the same thing happened with sodium. Sodium started out as a 0 charge, and then it became a positive charge here. So that means that sodium lost an electron. So if we start off at 0 and we take an electron off, then that means that we have more protons than electrons now, so the charge is going to become a +1. So if we write their half reaction for that, where we see sodium here is a 0, and here on the product side it's a +1, that had to happen by losing an electron. So you see here the electrons are on the product side. And here we have the electrons on the reactant side, adding an electron to silver to make it 0. So these are called your half reactions, and that's important in oxidation reduction because you're going to be writing the half reactions. Because in oxidation reduction, since we have a transfer of electrons, one element is going to gain electrons while the other element loses electrons. It always happens in pairs. One gains, one loses. Because remember, we can't create or destroy matter, we can only change it. And that's what's happening in an oxidation reduction reaction. All right, so pause the video and write this down. We're going to fill in the blanks and we're going to talk about this. All right, so an easy way to remember what it's called when you gain or lose electrons is by using the acronym oil rig, because oxidation is losing electrons. So oxidation is losing, OIL, oxidation is losing, and reduction is the gaining of electrons. So rig, reduction is gaining. So if we see our equation here of AgCl plus sodium, silver chloride plus sodium yields sodium chloride plus silver, From our last slide that we had, we said that the silver gains an electron, and we said that sodium loses an electron. So if we have silver here that was a +1 and it went to a 0, the only way it can do that is by gaining an electron. So the silver was reduced. I'm going to write reduced here. All right, now the sodium started off as a 0. Remember, a 0 on this side? And it went to a +1. And the only way that sodium can go from a 0 to a +1 is by gaining an electron. By losing an electron, because it's on the product side here, so it lost that electron. So oxidation is losing electrons. So the sodium was oxidized and the silver was reduced. So if filling in the blanks here, so the charge is becoming more in reduction. So here, the first one, the silver, if something is being reduced, then the charge is becoming more. Sorry, that was the phone. All right, so again, in reduction, the charge is becoming more, and it's wanting positive or negative here. Well, we are already positive here. So if it's becoming more positive, then it would be a +2 instead of a +1. So in reduction, the charge is becoming more negative because we're adding electrons. So when you add electron, the charge becomes more negative. And on the flip side, oxidation, when something is being oxidized, then the charge is becoming more positive. Okay, because now we're losing electrons. So if you lose an electron, the charge becomes more positive. All right, so in oxidation, the element is in gaining or losing electrons. Okay, so it's losing electrons. And over here in reduction, the element is gaining electrons. All right, and in the half reaction, the electron is and it wants there a product or a reactant. So let's look at oxidation right here. So is our electron, when we write the electron, a product or a reactant? Well, for oxidation, the electron is a product because it's on the right-hand side of that yield sign arrow. And if it's a product in oxidation, then in reduction, it's going to have to be a reactant. So make sure you have this written down and filled in, because that's going to be really, really important. Because it gets kind of confusing because electrons are negatively charged. So it gets kind of confusing. When you gain an electron, you get more negative because electrons are negative. But you're using that word gaining. So that kind of throws your brain off thinking that if you gain something, it's more a positive direction. But remember, the electrons are negative. So you're gaining a negative charge. It's becoming more negative. All right, so let's look at an example. Calcium metal is placed in a solution of tin to nitrate. All right, so we have calcium metal. We're going to place that in a solution of tin to nitrate. So tin is SN, and it's a +2. That's what that 2 means, that the charge is 2. And nitrate is NO3. That's a polyatomic ion with a -1 charge. All right, so the first thing we have to do is look at the activity series to see if calcium is stronger than tin. Well, here we have calcium, and here we have tin. So calcium is stronger, so calcium is going to push out the tin, and we're going to get tin by itself because it was pushed out, plus calcium nitrate. All right, so here calcium is a +2 charge. We get that from the periodic table. Nitrate is still a -1 charge, so we have to swap and drop to make a good formula. All right. And so the first thing that we want to do is assign charges. So tin is by itself, so that's going to be a 0 there. Calcium's by itself, so it's a 0 there. Now we want to make sure that we balance this equation. So we have 1 calcium on each side. We have 1 tin on each side. And on the left side, we see nitrate, we have 1. But on the right-hand side, we have 2. So I need 2 nitrates over here. Now that changed tin, so that made tin have 2. So I have to come over here on the right and add a 2 there. Okay, so now we have to see what elements change their charges. Well, calcium, let's start here. Calcium went from a 0 to a +2. All right, so how does calcium go from a 0 to a +2? Well, it had to lose 2 electrons to do that. So it had to lose 2 electrons. All right, so losing, oxidation is losing electrons. So let's go back. So calcium is being oxidized. It's becoming more positive. So we can see here that it's 0 and it's +2, so it's becoming more positive. So the element is losing electrons, so oxidation is losing. And so in the half reaction, the electron is going to be a product. So we're going to write here 2 electrons because it had to lose those 2 electrons in order for that to happen. All right, so let's look at that. If this lost 2 electrons, something had to gain 2 electrons. So here we have tin started out as a +2, and it went to a 0. Okay, so something had to happen to tin. Well, it had to gain 2 electrons because it's a +2, and here it's a 0, so it had to gain 2 negative charges to counterbalance these 2 positive charges that we have right here. So it had to gain those electrons to become a 0 charge. So this is reduction because reduction is gaining. This is oxidation because oxidation is losing. Okay. All right, so we have tin gaining 2 electrons to become tin 0, and it's being reduced. And that's all it is. That's all oxidation and reduction is. So we're going to do more and more examples during class. So make sure that you have your periodic table because you're going to need to know what the charges of all of these elements are. All right. So thanks for watching. Make sure you slap that like button right across the face. And if you haven't already, click that subscribe button and also click the notification so that when I put up new videos on YouTube before I put them on Canvas, then you'll know when I do that.